All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we're saying let's find the force in members B, C, CF, and EF of our truss shown. And then we're given our support reactions. Again, hopefully we can do that rigid body equilibrium step, make a free body diagram of the entire truss, find our support reactions. If this was a homework problem, that'd probably be your first step in here. But let's move past that and just give it so we can focus on the truss parts of this. So we have our support reactions given. Our first step, let's come in and mark off what pieces I'm looking for. I'm looking for what's going on in member BC. So I'll put a tick mark on it. BC. What's going on in member CF? Just directly down below it. And directly below that, what's going on in EF? So come down one more time and get that one marked off. And I get a choice. I can slice straight down through those. I can section through all three of them, no problem. So we'll draw that in. If I just section straight down the middle of this truss. And then my choice is, do I want to circle to the left and go through the pin? Do I want to circle to the right and go through the roller? Really on this one, it's a toss-up. It's the same amount of work either way. To the left, I'll have a 10 kilonewton force, AX and AY, 3 forces. To the right, I have 15, 5, and my roller force, 3 forces. It's the same amount of drawing. Literally, we just want to choose one of these directions and go for it. I'm going to circle to the right with this. I'm circling around to the right. We're making that free body diagram. Everything outside of this circle is getting sliced away, sectioned off. We don't include it in our free body diagram. Just the members that are in here and all of those forces that are applied at the internal pins then. So let's go ahead and draw our free body diagram. I'll just get that on the right. I have my uncut members. I didn't cut member CE, I didn't cut member DE, and I didn't cut member CD. So just 3 pieces of this I need to draw on here to make a nice triangle. At D, I had a roller. We were given dy was 13.33 going up. So 13.33. I know at E, and I'm making my cut somewhere after E, so I include this, I have 15 kilonewtons coming down. My width of this was 3 meters. Let's get that labeled. My height in here is also 3 meters, so label that. And then I can start getting my members that I cut. As I leave E, somewhere between E and F, I cut member EF. So that'll be a force for us, an FEF, force in member EF. I also cut through member CF up here at C, so I need to get in a force here. It goes down and to the right, or down to the left, FCF, and it would eventually intercept with FEF out here at point F. So we'll mark that off as well. This is point F, and my distance here is also 3 meters, despite what my picture looks like. I left off a force on accident. Up here at C, I should have a 5 kilonewton force going to the right. So we'll include that in there. And then the last thing, I cut member BC. So somewhere in between B and C, I need to have my force in here. So we'll draw in a force going to the left towards where we made our cut, and that is FBC. And I assume tension in every single member as I start these every single time, FBC. 3 unknowns in here, FBC, FCF, FEF. I should be able to find all of them. So let's come in and tackle that. Also, I need to label this angle in here. But do I know that angle? Well, if FCF goes over 3 meters and it goes down 3 meters, even without punching this into our calculator, we should know that's a 45-degree angle. Or we could do the inverse tangent of 3 over 3 and it would get us there. Either way, 45 degrees. But let's come in and work with this then. So what should we do first? I'm going to get some moments at F. I'll get rid of FCF and FEF with that, leaving me with FBC. So with positive, going counterclockwise, let's sum up our moments about point F. This is going to get me, well, that 13.33 will cause a counterclockwise rotation. So 13.33 for my support reaction from dy times 3 plus 3, 6. That 15 will cause a clockwise rotation. So subtracting it, minus 15 times my distance here is just 3. I'm summing moments at F. so I don't need to include FEF, and I don't need to include FCF. I do need to get this 5 kilonewton and FBC in here, though. My 5 kilonewton will cause a clockwise rotation minus my force is 5, and my distance vertically is just 3 meters times 3. Finally, my FBC will cause a positive rotation, and it's 3 meters away. So plus 3 FBC gets us to 0. FBC is my only unknown in here. If I solve for FBC, I get that the force in member BC is negative 6.67 kilonewtons. And that's negative in my setup in here when I assumed it was in tension. That negative, though, is telling us we're really in compression. So I'm going to put in a dashed arrow showing I now know it's really going this direction for FBC. It's in compression. And we always, for trusses, want to report our answers as a positive. FBC is a positive number, 6.67 kilonewtons. But then rather than saying T for tension, negative in tension is a positive. We already fixed that part. In compression. So let's stick a C on here. Anytime we're working with trusses, we should always be giving our answer as a positive number and then say T or C for tension or compression. But from here, I have 2 unknowns left. One in the Y, one in the X. Let's sum forces in the Y, and I'll get FCF out. If I sum my forces in the Y direction, I have 13.33 going up. 13.33 going up. I have 15 coming down, minus 15. The only other Y force is FCF, so minus its Y component. Minus FCF sine 45 is going to get us to 0. Solving for FCF, I would get that FCF is negative 2.36 kilonewtons, and that was when we are in tension that we originally assumed here. Always start out and assume tension. FCF, that means we're really acting in compression because we got a negative. So put in our dashed arrow. So if we use FCF again or FBC, we'll use it with the correct direction in there and treat it as a positive force. That's really, as we report our answer, FCF. Instead of saying it's negative in tension, report as a positive and change that T to a C. 2.36 kilonewtons in compression. Negative tension is a positive compression. Always give our answers as a positive and say T or C. But I have one unknown left to go. I could sum forces in the X and I would get it's FEF that I have left. That's totally valid for us. Or I could come in here and say, a bunch of my forces pass through point C up here. If I sum moments at C, it's actually going to be my easiest approach in here. So let's do that. With positive going counterclockwise, let's sum up my moments about point C. When I sum moments at C, I will have my support reaction dy will cause a counterclockwise rotation, and my distance is 3, so 13.33 times my distance 3. My 15 would go through C. FEF would cause a clockwise rotation, so I subtract it off minus my distance is 3, that vertical distance, minus 3 FEF. And then everything else is passing through C. FCF, FBC, 5, we already mentioned it, but this 15 down here, really there's only 2 things causing moment about C. This is going to get us to 0. And we should pretty easily be able to solve that one in our heads. The 3's are going to cancel. If we move FEF to the other side then, we just have FEF equals 13.33. FEF equals 13.33. I'm going to line that up better. Equals 13.33 kilonewtons. And we're getting a positive number out here. We assume tension always to start out. So we'll put a T on this one. In tension. Getting our answer still as a positive with T or C reported in there. Hopefully this is a useful video for you. If it was, Hit those like and subscribe buttons. Stick around. Let's get you an A with JJ.